Hello class. So today we will be talking about the R lab session. This is our second lab in R, or I would call it lab 1, right? Because in the lab 0 I just gave an exposure of R. So this is our lab 1, okay? So what we are going to learn in this class is that the first what we have to do is to summarize and describe the raw information, right? So whenever we are dealing with any data, the first thing we need to do is to summarize it and describing the raw information, right? And in these data sets, we will see some graphical and numerical summaries of data set. And this data set is actually, collected by the Center for Disease Control and Prevention, which is the CDC. And here we will also learn about the data processing and subsetting of the things, so which I'm going to actually talk later, right? So first, let's get a feel of the behavioral risk surveillance system, which is an annual telephone survey of 350,000 people in the United States, right? And the BRFSS, okay, let me just highlight that, which is the Behavioral Risk Factor Surveillance System, is designed to identify the risk factors in the adult population. Okay, so this like the system is actually, is mainly designed to identify the risk factors in the adult population and report the emerging health trends. All right, and for example, that respondents would be asked about their diet, weekly physical activity, for example, if they exercise or not, their HIV, AIDS or status, whether they smoke or not, and whether they have some kind of health insurance, or you can say healthcare coverage, right? And if you actually want to know the details, you can actually go to the BRFSS website, right? They have a complete description of the survey, including the research questions that motivates the study and many interesting results that come up from this data, right? So there are total 350,000 people in the BRFSS, but in our sample we have a sample of 20,000 people, and we have over 200 variables in this data set. Okay, but we will actually work with a small subset, right? We won't have so many variables in our data sets. So first, what we have to do is, first we need to load the data, if you recall from our first lab. So let's select this, like we copy this, and we always have to, define a source for R, or else it can't read it. Okay, so most important thing here is that we should define the source and we paste it. So I kind of actually, define the source here already, right? And then I clicked name CDC. So CDC is the file name. If you put names and CDC, what we will get is the name of the variables. All right, so a common mistake many students make is like they put the names and then just write CDC, but this CDC should be in parentheses, or else you won't get the variable names from the dataset. So if we have to find the variable names from the datasets, we always have to type names and then in bracket or in parentheses CDC. All right, and always remember that first thing is you have to define the source. So now we have got these 8 variables in our datasets, right? I said in the BFSSS there are total 200 variables, but we are only going to work with only 8 variables, right? So if we go back, and so what are these 8 variables? Okay, so we have Gen Health, right, from our thing, EXERNE, Health, HLTH plan, Smoke 100, right? Height, weight, WT desire, age, and gender. So we have total 8 variables, right? And so what are these? Gen health is the like people's general health, like how respondents evaluate their general health. So gen health is for like a general like how respondents are evaluating. And EXERANY, this is a variable which indicates whether the respondent exercised in the last month or not. Okay, so if they exercised, then it's 1. If they didn't, then it's 0, right? Similarly, HLTH plan indicates whether the respondent had some form of health coverage or did not. Okay, so if they had health coverage, then it's 1. If they did not, then it's 0. Whereas the smoke 100 variable indicates whether the respondent had smoked at least 100 cigarettes in her lifetime. Okay, or in his or her lifetime. So the other variables, like if we go back, the other variables are weight is for the respondent's weight, WT desire is the desired weight of the respondent, age is the age of the respondent, and gender is the gender of the respondent. So it could be either male or female, right? So those are the variables that we have, right? So you can actually read through the description. So first, in this exercise, we want to see how many cases are there in this data set, or in other words, how many variables. We have already seen there are total 8 variables, and for each variable we need to identify the data type, right? Whether it's a categorical variable or whether it's a discrete variable, right? So we can have a look at the first few entries of our data with the command. If you recall, we also did it in our first class. So if we copy this command, right? So I'm just copying this command, Control C, and I go to my R console. If I write head, and always remember it should be in bracket. Okay, don't make this mistake. If you don't put the bracket or the parenthesis, R will give you error. So let's see head CDC. We can see that for general health, okay, so we have some, so we can roughly see like how many types are there, right? So head, usually when you type head, it will give you the first few observations of the CDC. Okay, it's not giving you all the variables, like only the first observations. So now, similarly, if you write tail CDC, okay, let's copy and paste it. It will give you the last few observations. So usually it, in my case, they are giving the last 6 and the first 6. So when you type head, it's giving you the first 6 observation. When you type tail in bracket CDC, it's telling you the last few observations. Of course, you can say that you want to look at all the observations, but we know that CDC has 20,000 rows, so viewing the entire data set would make the screen very messy. Okay, so I don't recommend like you to see all. Okay, so it's better to take small peeks at the data with head, tail, or the subsetting techniques. So subsetting techniques is very important. Like you don't want to skim through all data, right? So you just want to subset it, like maybe the first 100 observations, or maybe the last 100, or maybe you want to see the middle 100, for example. Okay, so now let's look at some of the things that we can do with R. Okay, so a first thing is actually to find a summary of the statistics and graphics. Okay, so summary, like the things that are important. We may want to look at minimum, or we may want to look at median, mean, the quartiles, or the maximum, right? So if you write summary, then in the parentheses first you have to write CDC, and when you give the dollar sign weight, what will it give? It will give you a summary of the weight, right? So again, I copy this command, I go to my R, I press summary. CDC is because it's getting the data from the CDC, right, which is described in the source, right? And then dollar weight, so it will give you the weight summary. So in the weight summary, I see that the minimum weight is 68 in pounds, maximum weight is 500, median weight is 165, and the mean weight is 169.7, right? So we know the summary of the weight. So similarly, you can find, let's say I want to find the summary of age, right? So summary, first thing, type the name of the file, then give a dollar sign and type the name of the variable. So we have 18 years old minimum, maximum we have 99 years old, so median age is 43 and mean age is 45. So there are maybe a lot of like 40 ish people in the data set, and first q is the first quartile, third q is the third quartile, so you can easily find a summary, right? Okay, so now we know how to find summary. Now let's say we want to find the mean of the weight, so just write mean. Okay, mean, then name of the file and write the name of the variable, the mean you want to find. So we found the mean of the weight. Okay, so mean of age would be like 45, right? So you can find mean, you can find variance, you can find median. So let's also find variance. Very large variance here, median as well. Okay, so what I want you guys to do is actually repeat these steps that I am doing, and I want you guys to find me the summary, mean, variance, and median of weight, and then maybe you can print this out, right? So easy way to print is file, go to print, and print your scripts. Okay, so print, and then you can select the printer. For me, okay, I use a Canon printer. So if you print that, the whole thing, whatever you have done, right? So once, and you guys have to submit this to me on Monday. I haven't finished yet because there are 20 to 30 more minutes of video. So whatever I am doing, whatever comments I am doing, you guys should repeat the comments and submit to me on Monday. Okay, so this way I know that you are participating in the at least you are doing participating in the lab. Okay, so similarly we can also find a table. So let's say we want to find a table of, so not only mean, median, so let's copy this. So let's say we want to find a table for the smoking variable, so just write table, again in parentheses write the file name, dollar sign, then the variable name. Here the variable name is smoke 100, right? So it gives you a table. So 0 means did not smoke, so 10,559 people did not smoke. 1 means 9,441 people smoked. 1 indicates smoking, 0 indicates not smoking. Okay, so you can also find table for let's say for weight. All right, so this is getting a little bit messy because like there are people who are 68, there's only one people there. People weighing 95 is 22 pounds, right? um, people weighing 115, there are 244 people. So this gets a little bit messy once we find weight. So you can ignore a table for weights, right? Or you can include as well, right? So we know how to find mean, we know how to find median, we know how to find a summary. Okay, these are the key things that I was talking about. So obviously, like, we know how to find those things, right? So summary known, mean, variance, these are known, right? We can do those things quite easily, and also we can find a table, right? And if we want to find a relative frequency distribution, since there are total 20,000 people, we just divide it by 20,000. Okay, and paste this. We get the relative frequency of like 52% people do not smoke, 47% people smoke. All right, so that's how you find the relative frequency distribution. Another thing what you can do is, like, you can even find a bar plot of the table. Okay, so you are actually wanting to find the bar plot of the table. So copy this. So the table has zeros and ones, so it's showing that 10,000 people do not smoke and only 9,000 something 400 people smoke, right? So you can get the bar plot of a table as well. All right, so that's also pretty easy. uh, Now if you sometimes you want to see a table, this is sometimes called a cross tab in Stata. Okay, so let's say, okay, I'm just writing it down. This is called cross tab. Okay, cross, it's a cross. So we want to see that how many people smokes according to gender. So in that case, let's copy this, right? And let's look at here. See, 4,000 males do not smoke, 5,000 males smoke. Among females, 6,000 smoke, do not smoke, and 4,000 smoke. So see, when we include two tables, so male female is on this side, see the gender is on this side, and smoking comes on this side, right? So if you, whatever variable you put first will come in this way, right? So it will come as in this way, and whatever variable you put second would come in this way, right? So, and this is like a cross tab. Okay, so you guys should know how to formulate a cross tab. Okay, we also will see what's a mosaic plot. So let's see. Control C, you paste it, so we get a mosaic plot. So among males, relatively more males smoke than females, because one, so mosaic plot is very nice, right? So it's very ideal to actually see it like visually, right? All right, okay, so if you want to know the dimension of your data set, what we have to do is just type dim, always in bracket, cdc. So let's see. So it's 20,000. That means number of observation is 20,000. So there are 20,000 rows, and 9 means there are 9 variables or there are 9 columns. All right. So it's a 20,000 by 9. And let's say you actually want the sixth variable of the 567th respondent. Okay, so let's say you are a, like, you got the name of the patient, and that patient is the 567th respondent, and you actually want to know the sixth variable of that patient. All right, so in that case, in that case you have to first type this, right? And so let's go to the data CDC, right? And then in bracket, in fact this bracket is slightly different, so exactly follow that order. So 567th observation, you want to see the sixth variable value. So what is the sixth variable? And the sixth variable value is 160. So sixth variable value, let's go to name CDC. We will know what's our sixth variable. 1, 2, 3, 4, 5, 6. Sixth variable is the weight. So that's 160 pounds. So the person, the 567th patient has a weight of 160. So if we want to find, let's say, the height of 257th person, we write CDC, then put the bracket. We want to find the 257th person's height. Height is which variable? 1, 2, 3, 4, 5. So it's a fifth variable, right? And put the correct one. So we know that the 257th patient, and 5 is the variable, is the height. Its height is 65 inches. This is given in inches. So 65 inches is roughly 5 feet 5, or roughly maybe 160 to 170 centimeter. Okay, so they have used inches there, right? Let's say you actually want to find the weights for the first 10 respondents. So you want to see the weights of the first 10 respondent. In that case, what you do is you type CDC, in bracket you write 1 to 10. That means you want to see the first 10 people and you want to see their weight. So let's type this. It gives the weights of the first 10 patients. Let's say I want to see the age of the last 10 patients. So CDC, last 10 patients is 9,990 to 20,000, right? And I want to see their age. Age is seventh variable in the data set, right? All right. So I will see, is it 1, 2, 3, 4, 5, 6, 7? So, oh, sorry, this is the weight desired. This is not the age. Age is actually the eighth variable here, right? So I made a mistake. Okay. So CDC, last 10 people, the eighth variable is your age. Yes. So there are 10 observations, right? In fact, there are 11 because we also included 1990. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we got the last 11 persons. 8 represents the eighth variable, which is the age. Okay, so we got the age of the last 11 respondents. And if you just want all of their data, then you don't have to specify a variable name. You can just write CDC. Okay. Instead of mentioning the variable, it will show all the information of the first 10. Right. So we got the first 10's health good, very good. If they exercised, 1. If they have health plans, most of them have health plans. Most of them are, well, like pretty standard figures. Let's say we want to see how many people have health plans and how many don't have health plans. So if you want to see, so we can use, like, for example, table, right? So table, in bracket CDC, then the dollar sign, and health plan bracket close. So 17,000 people have one, that means 17,000 people have health plan, and only 2,500 does not have health plan. So if we want to see in terms of per percentage, we will write table CDC dollar health plan divided by 20,000. So 12% people don't have health insurance, 87% people have health insurance. Okay, so this is the frequency. And you can ask why I asked 20,000, because there are total 20,000 observations, right, in the table. And if you want to see all 20,000 respondents only the weight variable, then you don't write anything in the first observation, but you write for the second, right? So you want to see the way, like weights of all people. So it's pretty straightforward. And another way of actually seeing the weight of the 567th person is by this method, right? So Control C, CDC dollar weight, and in bracket you write 567. You get 160 pounds. Or I can write it like this: CDC, right? CDC. Let's look at that which we used. In bracket 567th peoples, and weight is the sixth column. You see, I made an error here because it shouldn't be parenthesis. It should be the other bracket. So CDC 567 6. So there are two ways of actually finding the 567th person's weight. Either you write CDC weight, and then in bracket you write 567, so it will give you the 567th observation, which is 160. Or you can mention CDC in this type of bracket, the closed brackets, you write 567 and then you define the weight, which is the sixth variable, and you get the same answer. So I actually prefer this method rather than actually this, because you don't know what's the sixth variable, right? Sometimes you make mistake, like what if sixth variable is age. Instead you can write CDC, you write the name of the variable, then you write the person's name. So whichever method you feel comfortable, it's up to you. Or similarly you can find the weight of the first 10 observations like this. Okay, CDC weight, and you want 1 to 10 instead of writing like CDC 1 to 10, right, and then comma 6. It's the same, right? You can do it either by this method, or you can also find the weight of the first 10 by this method. Whichever you feel comfortable is up to you, right? So you know how to use subsetting, right? Another way of subsetting is like if you just want to look through the gender. Okay, let's say you want to look through gender of, let's say, the first 100 people who is a male, right? So CDC gender, you define first 100 people and equals to male. Out of 100, all the trues are male and all the false are female, right? So that way you can also get some idea, right? Let's say you want to find person age who are above 30 in the first 10 observations. So you type this, and in bracket you mention that you want the first 10 people. In the first 10 observations, how many are true? 4, 5, 6, 7, 8. 8 people are above 30. In fact, 9 people are above 30, and only 1 people is not greater than 30. All right. So this is how we do the subset, right? So suppose we want to extract the data just for men in the sample, right? Or just for those who are above 30. So we can use this command. So aim data subset CDC gender should be, subset should be male, and there should be something wrong going on, right? Or maybe something is processing. Oh, no, actually what it did was it created a data set called aim data. Now you can see head aim data, okay? So head aim data, it will show you the first few observation of the males, right? So I actually have created a subset data set, okay? So this is a feature which is not, maybe it's not, available in Stata. So you can create a subset, so you only want the male data, or if you only want, let's say, the 30, you can create subset CDC and like age above 30, and you can put CDC age is greater than 30, right? So we can do that subsetting. So let's name that age, right? Age data, right? And we want to subset it. So name of the file cdc uh, age which is greater than 30, right? Close. And age data is, there's another data set. All right. Now if you want to find the head of age data, the first few observations who are above 30, so these people are all above 30 will be shown. Okay, so make sure you understand how to subset it, right? So I have actually created a subsample. Okay, so this is very powerful in R. In other softwares you may not get this kind of power. Okay, I actually have done that, right? Make sure you guys read through this. Let's look at how to form a box plot for the heights. So I'm just typing box plot, name of the file, and the height variable. They will give you a box plot, right, of all the data. Now if you want the box plot to be, let's say, um, if you want that it should be the box plot, let's look at other things as well. So according to gender, yeah, actually I was trying to talk about this. Let's go copy this, then you paste it. See, you can use this one, and you want to see the box plot for male and female, so that way you can see the box plot for both the genders. All right. uh, Another variable, let's say we want to create, we can create a BMI. So what is a BMI? BMI is weight over height square, right? So this is the formula, right? So we can copy this, go over there, right? Weight over height squared times 703. Okay, so they have created a new variable. So now if you write head CDC, you'll see an additional variable is there, right? 1 2 3. Okay, let's look at this. See the body mass index. Excellent, very good, good, fair, poor. All right. We can also draw an histogram of this, the age. More people in the 40s, see? And histogram of the BMI variable that we just created. More people are around 20 to 30, right? So it's pretty powerful, R. I want you guys to actually download this tutorial. This is actually on Blackboard. So you can find this on Blackboard, and you can practice these art things. And after you do all those things, you can just go to File, you print, you select the printer and print it and submit it on Monday. Okay, thank you so much. I hope you guys have a good weekend. See you guys on Monday.